Well, in this rather short video, we're just going to do two examples. And the first is going to talk about the experiment is to select a Faulkner University student at random. So one student out of the entire student body will be selected. Let E be the event that the student is taking math, so some math class. And let F be the event that the student is taking history. Okay, so we're going to complete the following, and we're just going to fill it out in words. All right, so complete the following. E intersection F is the event that the student is taking. Let's see, what is intersection? The student would have to be in both of these sets in order to be in the intersection. So it's the event that the student is taking both math and history. That's just the definition of what intersection means. So it'd be the elements, if E is the set of all students taking math, and F is the set of all students taking history, the intersection would be the students that are in both sets, taking both math and history. E union F would be the event that the student is taking either math or history. Now, remember in English what our word or means. It really means either one or both. So I'll put in parentheses, it's not necessary, but I'll go ahead and say or both. If you're taking either one or both of history and math, you're going to be in this set of E union F. Okay? E prime is the event that the student is not taking, let's see, E was math, so is not taking math. So if you're in E complement, that student is in E complement means that student is not in E, is not in the set of students taking math, so he would be or she would be not taking math. And let me back up a little bit more. F complement is the event. Let's see, F was the event that the student is taking history. F complement is going to be that the set of students not in this set. So it's going to be not taking history. So just as a reminder, if you are in let's see, if you're taking either one of them, you're in this set. If you're taking both, you're in this set. So actually, if you're taking both, you're still in this set because this is taking either one or both. All right, so if you're in the intersection, you have to be in the union as well. If you're in both of them, you're certainly in at least one of them. All right, now here's something we need to memorize, and it's fairly straightforward. Suppose E is an event in a sample space, and remember what that means. It means E is a subset of S. What is the probability of E complement? Well, in this one, we need to assume that we know, or we can just write it down as we know probability of E. Okay, and I mean, if we don't, I'll just represent it as P of E, the probability of E. Well, if E did not occur, and no matter what happens in the experiment, either E will occur or it will not occur 100% of the time, right? So, for example, if I roll a die, and let's say I'm looking at the event E being a number 1 shows up. 100% of the time, with probability 1 or 100%, either it is a 1 or it is not a 1. I hope you all agree with that. So the probability of E complement is the probability that E did not occur, which is simply going to be 100% or 1. Let me write this down. The probability of E complement is 1 minus the probability of E. We mentioned that in the previous video, I think. That another way you can write this is simply the probability of E plus the probability of E complement is equal to 1. Because with 100% certainty, either E occurs or it does not occur. If the probability of it raining tonight at midnight is 10%, the probability of E complement is the probability that it's not raining at midnight tonight. So if that's 10%, that would have to be 90% to add up to 1 or 100%. Remember, 1.0 is 100%, depending on if you're using decimals or percents. So something you will definitely want to memorize and remember. And it makes common sense, actually.